Hello and welcome back to Ganesh Institute and in this series of linear algebra. So today we are going to discuss about non-homogeneous system of linear equation. Now there can be a set of inconsistent and consistent solutions like when there is no solution exists and when there is a case of unique solution and infinitely many solutions. So let's get started.
What are non-homogeneous system of linear equations? So if we have to say that system of non-homogeneous, that means the set of equations should not be equal to zero. Should not be equal to zero. It has to have some value here. We have already talked about homogeneous, so we know what is A, what is X. A is a coefficient matrix and X is a column matrix of variables, and B is the value which is given to us equating the equation. So whenever we are given with, for example, we have a system of equation like a1x, b1y, c1 equal c1z equals m, a2x, b2y, c2z equals n, and a3x, b3y, c3z equals MNO or P. Okay, so coefficient matrix here, tell me. A1, B1, C1, coefficient of X, coefficient of Y, coefficient of Z. Then A2, B2, C2. Similarly for third equation, A3, B3, C3. So these are X2. This is X and here also it is X. Okay. Okay, this is a coefficient matrix. And what is column matrix here? Column matrix B. It is the value which is given equating the equation. What is X? The column matrix of variables. Okay. So how do we calculate the solution for non-homogeneous system? So here you need to see whether a particular equation is inconsistent, that is having no solution, or a unique solution, or we can say infinitely many solutions. Whenever the rank, now again there is one more point which you need to understand. We have understood how to find coefficient matrix and variable matrix and constant matrix. We need to make an augmented matrix out of it. So augmented matrix, let's say we denote it by C. Augmented matrix is represented as C equals A colon B. So here A is what? A1, B1, C1, A2, B2, C2, A3, B3, C3, right? Colon, what is B? M, N, P. Again, we have to find out the rank using whichever method you want, row elementary, echelon form, or minor form. So you can find out the rank. Okay, you create an augmented matrix, you find the rank using simply operations. Now if that rank of whole augmented matrix, this is not equal to rank of A, okay, then there is no solution. Now Rest two options are rank of augmented matrix is equals to rank of A. Rank of augmented matrix is equal to rank of A. Then we can move to consistent solution. But in consistency also we have unique or infinitely many. What to do then? Then you have already found out rank. Now you need to see whether this rank is equal to number of variables or not. If it is equal to number of variables, just like we used to do in trivial solution, homogeneous linear equation, trivial non-trivial solution, just watch that video. If rank is equal to number of variables, then unique solution. And if it is less than the number of variables, for example, here 3 variables are here. If the rank is less than 3, then we will say infinitely many solutions. Okay, let's try this out using an example. Let's say you have to solve a system of non-homogeneous. Firstly, tell me whether it is a system of homogeneous or non-homogeneous. What is the difference? Tell me. So basically, whenever you have here the constant value, which is not equal to 0, then this is non-homogeneous system. Now create a coefficient matrix. Coefficient of x is 1, y is 1, z is 1, 3, 1, minus 2, 2, 4, 7. What is b? Constants. Minus 3, minus 3, minus 2, 7. What is x? Variable matrix. Okay. Now what you do? You need to find out the augmented matrix. Create an augmented matrix out of it, which is C equals A colon B. Matrix of A colon B. So you're writing them together. That is 1, 1, 1, 3, 1, minus 2, 2, 4, 7. Here minus 3, minus 2, 7. Okay, now next step is to find out, to see whether this is a consistent equation, non-consistent solution. That is, if it is inconsistent, then there will be no solution. So answer will be finished there. Then if it is consistent, then maybe unique or infinitely many solutions. So firstly, the point is find out the rank. So rank, I can use elementary row transformation. This is already 1 here. So let's make these two zeros. R2 tends to R2 minus 3R1 and R3 tends to R3 minus 2R1. What have we got? By applying so, we are not doing anything here in R1. Now R2, 3 minus 3, 3 ones are 3, 0, 1 minus 3, minus 2, minus 2, minus 3, minus 5, right? Then we have minus 2, you have to apply it together in B also. So minus 2, minus 3R1, that is minus 2 plus 3 is a 9, this is 7. Then we have R3 minus 2R1, 2 minus 2, 0, 4 minus 2, 2, 7 minus 2, 5. Then 7 minus, this is rough work, 7 minus 2R1. So 7 plus 3 to the 6, that is 13. Right? Next, what can we do? We have to try to make the whole row 0 with 0 elements if possible. So can we see, can I make these two 0? Okay, let's do it as R3 tends to R3 minus R2. So it will give us 111 colon minus 3. We are not doing anything with R2 as well. 7. Now 0 minus 0, R3. We should do R3 because it is minus, it is plus. So we should do plus, right? Instead of minus. So 2 minus 2 minus 2, 0. 5 minus 5, 0. 13 minus 7, 6. Oops. We are doing plus, no? 13 plus 7, 20. Okay. Now tell me, if I ask you, this is A and this is whole C, augmented matrix. What is the rank of A? You can see we have to count number of non-zero rows. This is whole 0. So we are left with 2 rows. So rank is 2 for A. But if you see the whole scenario together, you will see that this is not completely 0. We have 20 as non-zero value. So non-zero, 1, 2, 3. So rank of C is 3. Right? Tell me, whether rank of A equals rank of C? No. So if it is not equal, what we say? That this is a set which is inconsistent. And what do we mean by inconsistent? That this set of equation will not be having any solution. Question has asked us to solve, but we cannot solve it because the equation is not having any solution. But what if another scenario can come into picture? Let's say we have a question stating that you have this equation set. You have 2x plus 3y plus 5z equals 9, 7x plus 3y minus 2z equal 8, and 2x plus 3y plus lambda z equals mu. You need to find out the value of lambda and mu. But you know what are the conditions? You need to find out the value when the equation is not having any solution, when the equation is having unique solution, and when the equation is having infinitely many solutions. Now how to do it? Okay, firstly, if you are not getting, you are not getting anywhere, you can start finding out rank, right? So what we are supposed to do in rank? Firstly, because it is a non-homogeneous system, so AX is equal to B. What is A here? Coefficient matrix 2, 3, 5, 7, 3 minus 2, 2, 3 lambda. So jot it down, 7, 3 minus 2, 2, 3 lambda. What is B? It is 9, 8 mu. And what is X? The variable matrix X, Y, Z. So once you've got AX and B, find out the augmented matrix. How to find augmented matrix? C, which is A colon B, right? So A is 2, 3, 5, 7, 3 minus 2, 2, 3 lambda. Colon 9, 8 mu. Now in order to find out rank, let's apply at least to the extent which we know, apart from lambda and mu, we can try to make as many zeros as we can. So keep it as it is. We can try these two to be zeros. So R2 minus 7 by 2 R1 and R3 tends to R3 minus R1. It will give us 0 in first column at least. So R2, firstly R1 we are not doing anything here. R2 minus 7 R2, 7 by 2 R2. So R2 is 7 minus 7 by 2 R1. 7 minus 7, 0. Then 3 minus 7 by 2 R1. 3 to the 6 minus, what have we got? 21. 6 minus 21, that is minus 15 by 2. Then we have, we are doing R2 minus 7 by 2 R2, R1. So what is R2 next? This one. Minus 2 minus 7 by 2 R1, which is 5. So minus 2 to the 4 minus 7 5 is 35 by 2. That is minus 39 by 2. You could have made it simpler by making it 1 by dividing first row by 2 also. Okay. Then we have again R2 minus 7 by 2 R1. So 8 2s are 16 minus 9 7s are 63 by 2. 13 minus 6, 7. And then 5 minus 1, 47 by 2. Then we have R3 minus R1. R3 minus R1. 2 minus 2, 0. 3 minus 3, 0. Lambda minus 5. This was quick one. And mu minus 9. Right? Okay. Now the best part comes in. Firstly, here we have to check whether rank of A equals rank of C. If it is not equal, then we will say inconsistent solution, no solution. No solution. If it is equal, but rank of A equals rank of C equals, but less than number of variables, okay, less than number of variables, then what we say? Infinitely many. And if rank is equal, but it is also equal to number of variables, then we say unique solution. Okay, unique solution. So let's figure this out. How can we calculate rank here? Because we don't know the value of lambda and mu. What to do now? So let's suppose that rank is not equal. In which scenario rank cannot be equal? Tell me rank of A. If I consider that, okay, lambda minus 5 is 0, that is this whole row for A. Just see A, this is B. For A, this whole row is 0. That is lambda minus 5 equals 0. That is lambda equals 5. So if lambda equals 5, this will be a 0 row. So we will be having 2 non-zero rows. So rank of A will be 2. I have considered that rank is not equal to C. Rank of coefficient matrix is not equal to rank of augmented matrix. Okay. So that means for them to not to be equal, it has to be this mu minus 9 must not be 0. Yes or no? Then only, because if this mu minus 9 would become 0, then this whole row becomes 0 and it will make the rank as 2, which will be equal. Correct? So let's figure this out. That means mu should not be equal to 9. So this is when we want the system to be inconsistent. This is one scenario. The values of lambda and mu are these two. When system is inconsistent, rank is not equal. Okay? What if I want the rank to be equal? That is the next step to make it a consistent system. So if rank has to be equal, I have already found out the rank of A. Let's say if lambda minus 5 is 0. If lambda minus 5 is 0, that means this whole row is 0. That means the rank of A is 2. Non-zero rows. If rank of A is 2, I want them to be equal in both of the scenario, be it unique or infinitely. They have to be equal. So rank of C must be 2. Right? How can rank of C must be 2? Can become 2 if we have this value also 0. Right? Mu minus 9. So that means mu has to be 9. Correct? So in that case, when rank is equal, and I have here tell me the number of unknown values. How many are these? Lambda and mu. Right? Lambda and mu, and we have variables 3. Rank is less than 3. If rank is less than 3, that means the equation will be having infinitely many solutions at these 2 points. Correct? Less than number of unknowns. Infinitely many. What about the next one? To make it unique, it has to be equal to number of variables. That means rank has to be equal to x, y, z, 3. How can I make, let me write this structure again. So our augmented matrix is 2, 7, 2, 3, 3, 3, 5 minus 2 lambda, x, y, z. Okay. This should not be x, y, z. Columns B. B matrix is what? Hold on. I've messed this up. Okay, I need to write augmented matrix. This is 2, 3, 5. Here is 9. Then we have 0 minus 15 by 2, minus 39 by 2, and minus 47 by 2. 0, 0, lambda minus 5, mu minus 9. Right? This was the augmented matrix. Initially, I wrote the question itself. Right? Okay, this is the augmented matrix. Now I want unique solution. And unique means the rank has to be equal to number of variables. That is rank of A. A is this one. This is A. Is equal to rank of this C. And it has to be equal to number of variables, which are 3. X, Y, Z. How can I make the rank of C as 3? Only if this row, I need to count all of them, all these 3 rows, then only rank can be 3. So that means these 2 cannot be 0. Yes or no? That means lambda minus 5 cannot be 0. Mu minus 9 cannot be 0. That means in this case, lambda cannot be 5 and mu cannot be 9. Okay, clear? So these are the types of questions which you can expect when it comes to non-homogeneous system of linear equation.
If you really like this video, then don't forget to like, share and subscribe our channel. Till my next video, take care of yourself. Bye-bye.